Okay, get this. What if I told you a visitor from, like, the deepest, darkest corners of interstellar space just flew past the sun?
And not just that it flew by.
It reached its most violent, spectacular moment, the peak of its activity, and Earth was completely, utterly blind to the whole show.
It's more than just a missed opportunity. It was uh, a profound scientific blind spot. The critical data we needed, it was all happening exactly when our view was blocked.
The ultimate cosmic frustration.
Absolutely.
But the frustration is real, and luckily the data wasn't totally lost. Welcome back to Deep Dive Chronicles.
Glad to be here.
Today we are on a mission, tracking this mysterious interstellar object, 3I Ellis. We're going to figure out what this strange visitor is, why the timing was so bad for us here on Earth.
And how our network of solar system spies, specifically on Mars, swooped in to save the day.
It's a fantastic story.
It really is. I mean, this whole thing is a phenomenal demonstration of how orbital mechanics can work against us, forcing scientists to pivot these multi-billion-dollar missions just for a few fuzzy images.
Fuzzy images of something literally alien to our neighborhood. Okay, let's unpack this. We're calling it the ghost object.
Sounds about right.
So 3I ADOS, the 3I means it's the third confirmed interstellar object we've seen after Oumuamua and Borisov. It was spotted pretty early, back on July 1st, 2025.
Right, by the ATLE survey telescope.
But from the second we knew what it was, the clock was ticking toward, well, a disaster.
That's right. I mean, just the name 3I IDOS makes it fascinating. But its trajectory, its characteristics,
Yeah.
it's just not like any comet we've seen from our own Oort cloud.
What's the difference?
Well, Oort cloud comets have been shaped by our sun's gravity for eons. This object is pristine. It's unmixed material from a whole other star system. That alone makes it a top-tier scientific target.
And the whole problem was the timing. It hit perihelion, its closest point to the sun, on October 29th. So why is perihelion the main event?
Perihelion is the moment of truth. Comets are basically dirty snowballs, right?
Right.
When they get close to the sun, the ices, water, carbon dioxide, they don't melt. They violently sublime.
They turn straight from solid to gas.
Exactly. Superheated gas, creating those spectacular tails in the coma. And it's during that explosive phase that the comet vents its innermost secrets, its chemical composition. If you miss perihelion, you miss the core data.
And that's exactly what happened. Our planet was in the worst possible seat for the show.
The blind spot was absolute. As NASA planetary scientist Tom Statler put it, Earth was on the wrong side of the sun.
We were literally staring at the back of the sun while this thing was at its most active.
Yep. From late October to mid-November, our view was completely blocked. No ground telescopes, no near-Earth telescopes could see a thing.
That sounds like a complete data loss. I mean, for an object that's only here for a short time before it heads back into the void, do you just shrug and wait for the next one?
Historically, yes, that's exactly what would have happened.
But not this time.
But in the age of coordinated space assets, the answer is a definitive no. And this is where the plot twist kicks in. We might have been blind, but NASA knew exactly who had the front row seat.
Our orbital spy.
Our orbital spy.
And the unexpected hero of this entire deep dive is Mars.
Absolutely. Mars was in the perfect orbital position. It wasn't just on the correct side of the sun. The comet's path actually brought it inside the orbit of Mars.
So it was basically a neighbor just zipping through the Martian backyard.
Pretty much. And that meant all the spacecraft orbiting the red planet suddenly became the most important observatories we had.
I can just imagine the scramble at mission control. You have these cameras designed to look down at Martian rocks, and suddenly people are yelling, "Point them up, track that tiny dot."
That is the real story here. The sheer logistical genius of that pivot. The most vital observations came from the Mars Reconnaissance Orbiter, the MRO.
MRO is a workhorse, right?
It is, but its main camera, high-rise, is designed for super high-resolution shots of, static ground. To pivot that complex instrument and snap the comet from just 30 million kilometers away.
Wait, 30 million kilometers? That's 19 million miles. That's still really far.
It's an immense distance. And to track a tiny, faint, fast-moving object with a camera built for stability, that was a huge technical feat.
It sounds like trying to photograph a fly on the other side of a football stadium. In the dark.
That is a pretty good analogy.
Yeah.
They had to use extremely short exposures, specialized tracking algorithms.
Yeah.
Basically just treating the comet like a moving point of light against the stars.
So the pictures weren't crystal clear, but they were something.
They were a crucial optical view of the comet right before its peak activity.
Mm-hmm.
And MRO wasn't the only asset.
We also had MAVEN,
Right, the Mars Atmosphere and Volatile Evolution mission.
which usually studies the Martian atmosphere, so what could it do?
MAVEN provided the chemical fingerprint. It observed the comet in ultraviolet UV wavelengths. This is critical because water ice breaks down into hydrogen in sunlight.
Ah, okay.
By tracking the UV signature of hydrogen in the comet's atmosphere and tail, MAVEN gave us fundamental data on how fast it was releasing its volatiles.
So if it's venting more hydrogen than a typical comet from our system, that tells us something about where it came from.
Precisely. We can compare the ratio of water ice to other stuff, which gives us unique clues about the environment where this object was born, information you can only get near perihelion.
And the list just keeps going. Even the Perseverance rover down on the surface managed to get images.
It did. But it wasn't just Mars. This was a solar system-wide mobilization.
A scientific emergency.
You could call it that. Our solar observatories, Punch, Stereo, SOHO, they all briefly shifted their focus. Even missions way out in the asteroid belt, like LUCY and Psyche, they managed to snag sightings.
And I thought this detail was incredible. All of this happened even during the U.S. government shutdown.
It speaks volumes, doesn't it? About the dedication of these teams. They knew this was a once-in-a-lifetime chance.
But we have to be honest about what they got. The sources say the images are a little on the fuzzy side.
They are. We didn't get that 4K high-def footage the internet always wants.
So why are these fuzzy little blobs still so scientifically valuable?
Well, for compositional analysis, photographic clarity isn't everything. Even with a fuzzy picture, we can still measure the expansion rate of the coma, the shape of the tails, changes in brightness.
Things that tell you what it's made of and how it's behaving.
Exactly. That's far more important than a pretty picture when you're looking at material from another star system.
Okay, so we've established the data is sparse but critical. Now we have to address the elephant in the room.
Oh, yeah.
You can't have a weird, fast-moving object from deep space that we can only get fuzzy pictures of without the internet doing what it does best.
Screaming aliens.
Or, to be specific, alien death probe.
It was inevitable. The interstellar origin, the weird trajectory, the lack of clear images. It's the perfect storm for speculation.
Yeah.
People immediately started comparing it to probes or ships.
So what did NASA, the people with the actual data, have to say? They had to address it, right?
They did. NASA Associate Administrator Amit Kshatriya came out and gave a pretty definitive response. He said, and I'm quoting here, "I'd like to address the rumors. This object is a comet. It looks and behaves like a comet, and all evidence points to it being a comet."
So, sorry folks, no interstellar spaceship this time. But here's where it gets really cool and why the science is still so exciting.
Right.
Even though it's not a ship, it is still alien in the scientific sense of the word.
Absolutely. That is the defining feature. It came from outside our solar system. It's a traveler that has spent millennia in deep space. That makes it scientifically alien, which, as NASA said, makes it fascinating, exciting, and scientifically very important.
We're literally looking at the building blocks of another star's planets.
We are. And we have more physical evidence now, too.
Yeah.
There's that gorgeous photo taken by astrophotographer Satoru Murata from New Mexico.
Yeah, that was on November 16th.
And that photo is the perfect counterargument to the probe theories. It shows all the classic features: long, luscious, streaming tails, and a slightly green coma.
That green color is a dead giveaway, isn't it?
It's a key chemical indicator. It's often diatomic carbon glowing, which is completely consistent with a natural comet reacting to the sun. It's behaving exactly as an interstellar comet should.
So, we've got the data saved by Mars, we've debunked the alien probe theories, and we've confirmed it's a natural comet. But for us here on Earth, the show isn't quite over.
No, it is not. This is the big opportunity part. This is for you, the listener, to prepare.
Your chance to turn your gaze upward. When do we need to be ready?
The comet's closest approach to Earth will be on December 19th. And it's important to remember the Mars data was so vital because it confirmed the comet survived its trip around the sun. It didn't break apart.
So it's still out there for us to see.
It is, which makes this Earth flyby a real, viable observation window.
Okay, mark your calendars. December 19th. It won't be visible with the naked eye, but for amateur astronomers, people with good telescopes.
This will be the best window we have for capturing it from Earth. Because all that initial explosive activity happened behind the sun, this flyby gives us the clearest view to study the comet as it starts to dim and head back out into deep space.
It's kind of a perfect collaboration, really.
How so?
We needed MRO and a MAVEN on Mars to tell us what it was doing at its most violent,
Right.
so that now we can maximize our observations from Earth during its calmer exit phase.
That's a great way to put it. It's an orbital mechanics puzzle solved by pure scientific ingenuity. We used our robots millions of miles away to understand it when we couldn't see it, so we could be ready when it finally came out from behind the sun.
Absolutely fascinating. So to recap, we tracked an interstellar traveler, 3I Atlas. Earth was totally blinded during its peak activity, but thanks to the heroic, quick-thinking efforts of our Mars assets,
MRO, MAVEN, even Perseverance.
we saved the data and confirmed this thing as a genuine, though scientifically alien, comet.
And this whole thing just proves that these observations, even the fuzzy ones from 30 million kilometers away, are teaching us fundamentally new things about the universe. They're giving us insights into the physics and chemistry of objects from a whole different solar neighborhood.
It makes you wonder, though, given we had to rely on this massive emergency mobilization just to catch a glimpse, what does this tell us about the blind spots we still have in monitoring our own cosmic backyard?
That is the big question.
We want to know what you think. Do you believe NASA, or is there still a part of you that thinks it's a probe? Let us know your thoughts down in the comments.
I'm curious to see those.
And if you enjoyed this deep dive into cosmic espionage and orbital mechanics, smash that like button and subscribe to Deep Dive Chronicles so you never miss a cosmic mystery.
We'll see you next time.